What's up, everybody? This is episode 2 of my series on computer networking basics, and today I'm going over network topologies, types of network devices, and what are IP addresses. So let's find out. And when I say topology, I just mean the layout of the network, the structure of the network, and how it connects. And here are some examples. This is a point-to-point. It's very simple to configure. It's a direct connection between only two devices. This right here is a bus connection. It's easy to install. It's when all the devices are connected to one bus cable, but if the bus cable fails, all the networks go down. Here we have a ring. This is where each device is connected to two others. Data flows in one direction, so there's less data collision, but when you add or remove devices, it can mess up some of the devices' networks. We have a star network where all the devices connect to a central hub. It's good because if devices fail, it doesn't affect the overall network, but if the central hub fails, the entire network is gone. A mesh network is where each device connects to every other device. Very reliable. If one device fails, other devices can pick up slack. It's very complex and expensive, and they don't work for larger networks. A tree is like a hybrid of stars, multiple hubs, connected to almost like a bus backbone. If you see that top node, it's almost like a bus line. These are scalable and easy to manage, but if one of these backbone lines fail, it can make a large portion of the network go out. And a hybrid, of course, is when you have two or more from the other topologies into one. Right here you have a point-to-point mixed with a star, mixed with a ring. These are very flexible, very scalable, can be optimized, but they can become very, very expensive. Now I'm going to touch on types of network devices. And for the record, your modern router has probably 5 of these, everything but a server. A router, switch, wireless controller, access point, firewall. These all standardly come in with every router you buy now from Best Buy. So of course, first we have a router. All this thing does is connect our networks together and use IP addresses to direct data. Now a switch connects multiple devices inside the same network. So a printer, computer, server. It makes sure data goes to the correct device, and it uses MAC addresses. So like I said, a modern router will have a switch on the back of it. Here we have servers, very powerful computers that provide services like web servers, file servers, data servers, mail servers. They really are the backbone of most network operations. And finally, we have access points, wireless controllers, and firewalls. An access point connects wireless devices to a wired network. It extends network coverage, and it broadcasts the network name. Wireless controllers manage multiple access points. Firewalls protect traffic through those access points by enforcing security rules. And like I said earlier, most routers, most high-end routers, they're going to have all these three things built in. But as you can see, sometimes they can also be their own separate hardware device. So last thing we'll cover is IP addresses and kind of take a look at what they are behind the scenes. The first thing I want to do is go back to the OSI model from my last episode. If you look at this right column, you'll see data types. And for these first 4 layers, as you go up a layer, it changes the data type. On the bottom physical layer, you'll see bits. So what are bits? These are bits, zeros and ones. 1 represents on, 0 represents off, and all a computer really does when it processes data, it's really just processing it all as zeros and ones. These are different types of data measurements that computers will read. So as you can see, a bit is a 0 or a 1, a single binary digit. A byte is 8 bits, and then you have kilobytes, megabytes, gigabytes, terabytes. They just get exponentially larger than the previous one. So now we're going to get to the IP addresses. There's IPv4 and IPv6. IPv4 has been around since '81, and it's a 32-bit address. Remember that number, 32. IPv6 is a little bit younger. It was developed in '98, and it's 128 bits. For this video and fundamental understanding, we're just going to cover IPv4. So this right here is the IPv4 address format. You have 4 octets. Each segment of numbers between a period is an octet. So below these digits, for example, 185, you have this, 10111001. All these represent is the binary notation of this digit up here. And every number is going to have a binary notation. If you want to learn more about how to convert digits to binary, there's hundreds of other videos you can watch on YouTube that'll go in depth on that. So as I was saying, each octet's digit is going to have an 8-digit binary that the computer reads. And as you can see, they're all 8 digits, which means they're all 8 bits. This is where 32 bits comes from. You have 4 sets of numbers that represent 8 bits each. And this is really important for the future topics we'll cover. And when it comes to these IP addresses, the numbers between the octets have to be between 0 and 255. So the lowest you can have for an IP is 0.0.0.0, and the highest you can have is 255.255.255.255. And some people might wonder, why can't you go above 255? Why can't you have 256? Well, I'll show you. So like I said before, every integer that we know about has a binary notation. And when they set up these IP addresses, they wanted each octet to have 8 bits. So as you can see here, 255 in binary is 1111111. 8 digits, 8 bits. 256 in binary, however, is 100000000. 00000. This is 9 bits. So this wasn't going to coincide with the 8-bit octet format that they set up. So to summarize this, an IP address is a unique identifier for a device on a network. It allows your devices to connect to each other. Printers, routers, iPhones, laptops, anything that communicates with IP is going to need an IP address. In my next video, we're going to go more in depth on this and cover subnetting. That's it for this episode. Comment, tell me if you think I missed something, like, subscribe, all that, and I'll see you in the next one.